Alright, example number 2. Design the thickness of the footing. We check for the wide beam and the punching. So the service loads are given. The dead is 1,100 kilonewton. The live load is 900 kilonewton. F prime C is 20.7 megapascal and Fy is 380 megapascal. The dimension of the footing is square, 2.5 by 2.5 with a column at the center 0.4 by 0.4 meters. Okay, so we design the thickness of the footing. So alamin natin ano yung magiging thickness ng footing. So ang idea dito is dapat yung thickness natin or yung effective depth natin para sa wide beam and punching ay dapat pumasa. Alright, so if you remember, ang ating goal dito dapat ay, okay, for wide beam and punching, okay, for good design, if you remember, the allowable, okay, the VU allowable should be greater or equal to the VU actual. Okay? Okay. So, for both wide beam and punching natin to gagamitin. Dapat pumasa siya sa wide beam and dapat siya pumasa sa punching. So, ano yung thickness kaya na gagamitin natin using these two? Okay? So, unahin na natin dito yung sa may wide beam na part. Okay? So, for wide beam, dahil square naman ito, again, kahit saang side tayo kumuha ng critical section. Okay? So, i-copy natin ito. Ayan. So, unahin natin yung sa may wide beam na part na lang. Okay? So, for wide beam, okay, sukat lang tayo the distance from anywhere, no? So, siguro ito na lang yung gamitin natin na reference. Okay? So, ito ay the distance. So, ibig sabihin nito, yung section na to ay mapuputol o matatanggal. Okay? So, the distance po yan, ano? Ngayon, meron na tayo ditong width naman. Okay? So, for example, yung naputol na section na yan, ang kanyang itsura ay parang ganito kunyari. Okay? So, meron tayo ditong 2.5 meters. Tapos, yung kapal ay hindi natin alam. Okay? So, ito yung gusto nating malaman, yung thickness na yan. Okay? Tapos, lagay natin dito label na lang. Labelan natin to na x distance. So, ano yung magiging x distance natin pala dito? Okay? Yung x natin dito is simply, okay? So, 2.5 less 0.4 less d, tapos d dito sa kabila or 2d. Okay? Tapos, divide natin lahat ito ng 2. Okay? Oops. Okay, divide this by 2. Okay, so ito yung value ng x natin. So, in terms of d na lang siya. Okay, so pwede natin itong simplify. 2.5 less 0.4, that is so 2.4 minus, ayan, 2.5 minus 0.4, that is 2.1. Divide this by, oops, divide by 2. Oops, sorry. 2.1 divided by 2, this is equal to and 1.05 tapos minus d. Okay? So 1.05 minus, okay, 2 divided by 2, that is 1. D na lang. Okay? So yung x natin dito in terms of d na lang natin siya kunin. Alright? So meron na tayo ditong x na in terms of d, then isolve natin yung, okay, VU allowable. Okay? So meron din tayo ditong pressure, by the way, no? Okay, yung pressure dapat dito is dapat naka-ultimate. Okay? Para makuha natin yung value ng VU. Okay? So, magkakaroon tayo dito sa gitna ng VU. Okay? So, dapat ito ay QU. Okay? So, again, dito sa may gitna yan part, no? Na mag-a-act. Okay, so yung QU natin dito, solve natin muna. This is PU divided by the area of the footing. Okay? Or PU divided by the area of the footing. So, yung PU natin is simply 1.2 of the dead, which is equal to 1.1, tapos live load natin na 900. Okay, 1.2 ng dead plus 1.6 ng live, 900. Okay, divide this all by the area of the footing na equal to 2.5 by 2.5. Okay, so 2.5 is square. Alright, so ang ating QU dito ay equal to, okay, so 1.2 ng 1.1 plus 1.6 ng 900, divide this by 2.5 square. Okay? So, meron tayong QU na 441.6. 441.6 kilopascal. Okay? So, yan, no? Pwede na natin isolve yung VU dito. Or actually, pwede na natin tong idiretso. VU allowable is equal to VU actual. Para pumasa, no? Okay? Gusto nating malaman yung thickness. Okay? Isasagad na natin. Yung allowable, i-equate na natin sa actual. Okay? So, yun yung magiging working equation natin. Take note that the VU allowable should be equal to the VU actual. Okay? Now, ano yung VU allowable natin? Okay? So, yung VU allowable natin for wide beam, this is simply equal to phi VC. Okay? This is the phi VC. And then, yung actual naman natin, this is in terms of the pressure. Okay? This is QU times area shaded. Okay? So, yan yung formula natin. Phi VC is equal to QU area shaded. So, ano yung area shaded natin? Yung 2.5 by X. Okay? So, yung phi natin dito is 0.75. Okay? Yung VC natin, anong VC natin for wide beam? That is 1/6 lambda square root F prime C BD. Okay? BD is equal to QU 441.6 times the area shaded na 2.5 by X. Okay? So, yan. Substitute pa natin lahat. 0.75 is equal times 1/6 lambda natin. Walang binigay ulit. So, assume natin normal weight. 1 square root of F prime C. That is equal to 20.7. Okay? 20.7. Ano yung B natin dito? Yung B natin dito ay syempre yung 2.5, no? Dito nangyayari yung kiskisan. Okay, by the way, dito nangyayaring kiskisan. So, yung width natin ay 2.5. Okay? So, gawin natin to guys, no, na puro yung dimension natin ay dapat naka-meters muna lahat. Okay? Para ma-solve natin yung magiging effective depth. Okay? So, yung B natin dito, gawin natin tong 2.5 meters. Okay? Ito yung technique, no? Gawin natin tong meters muna, yung B. Okay? Tapos yung effective depth, that is unknown, no? Hindi natin alam. Okay? And then, naka-meters yung ating mga dimension, tapos yung loob ng ating F prime C, no? This is Newton per mm square. Okay? So, gawin natin yung Newton na kilonewton. So, mag-times tayo dito ng 1,000. Okay? Ayan. So, parang ganito lang yung technique, no? Mag-multiply tayo ng 1,000 dito sa may left equation. Then, sa right equation naman dito, gawin natin 441.6. Okay? Ito, naka-dimension na, naka-meters na rin naman. Yung 2.5, naka-meters na yan. Times yung x natin ay also naka-meters na rin. 1.05 meters minus d. Okay? 1.05 less d. Okay? So, yung unknown dito ay yung effective depth. Alright? So, masosolve na natin dito yung magiging value ng effective depth natin. Okay? So, pwede nating isimplify siguro muna lahat ng constant sa left. Gawin natin 0.75 times 1/6. Okay? Times square root ng 20.7 times 2.5 times 1,000. Okay? Divide natin yung mga naiwang constant dito sa may left. 441.6 okay, times 2.5. Okay? Tapos, store natin dito sa letter A na lang. Okay? So, ito yung kanyang value, no? Stored value sa A. Okay? So, alpha A, recall natin, is equal to, alpha A, okay, nandito sa left side, times yung x, huwag natin kalimutan, yun yung unknown x, distance, is equal to, meron pang naiwan dito sa may loob, yung parenthesis na 1.05 minus d. 1.05 less x na lang yan. Okay? And then, shift solve. Equate lang natin yan. Okay? So, yung effective depth natin ay 0.458. Okay? Or 459 rather. 0.459. So, ito ay meters na. Okay? So, wag muna ito yung i-adapt natin na answer dahil chine-check pa lang natin ito sa wide beam. Okay? Dapat din i-check natin ito sa punching. Okay? So, sino yung mas magbibigay ng mas makapal na thickness, yun yung mag-govern. Okay, so yung punching naman yung gagawin natin. Okay? So, i-copy lang natin to ulit. Okay, and then, this time naman, punching tayo. And punching. Okay? So, for punching naman, again, sukatin natin, no, d over 2 all throughout the side. Okay? So, for example, ito yung critical section na yon. Okay? d over 2 all throughout the side. Then, tawagin natin tong x and y. Again, this is square. So, x is equal to y. Okay? So, d over 2 distance ito, d over 2 distance dito sa my left. Okay? So, pwede natin sabihin actually na ang x ay simply column dimension plus d over 2 plus d over 2 or simply d na lang. Okay? Yung y naman natin ay ganyan din, 0.4 plus d syempre. Tapos, yung BO natin is equal to 2x plus y. 2x plus y. Yung substitute natin lahat, 2.4 plus d plus 0.4 plus d. Okay? Or BO is equal to 0.8 na yung nasa loob times 2 natin. That is 1.6 plus d, 2d plus 2. That is now, or times 2 rather, that is now 4d. Okay? So, ito yung magiging B sub O natin or critical perimeter natin in terms of effective depth D. Okay? So, underline lang natin muna yan. Okay, so ganun ulit, no? VU allowable natin ay also equal to the VU actual dapat. Okay? Now, ang allowable natin dito ay still, ganun pa rin naman, VVC. Then, VU actual natin ay QU area shaded pa rin. Hindi nagbabago. Punching man or wide beam parehas yung formula natin. Nag-iiba lang yung area ng shaded tapos yung value ng VC. Yung allowable VC. Okay. Unahin natin yung VC. Yung VC natin, meron tayong tatlong value for the VC. Okay? Meron yung 1/3, meron yung 1/6, meron yung 1/12. Okay? Kapag ka nagde-design tayo ng thickness, okay, since alam naman natin na madalas or in most cases talaga ang nag-govern doon ay yung 1/3 na formula, yung first formula, yun na lang din ang i-adapt natin dito para mas mabilis. Okay? So again, no, yung fee natin dito ay 0.75. Tapos yung VC na gagamitin natin ay yung first formula dahil in most cases, yun naman talaga yung nag-govern, no? So that is 1/3 lambda square root f prime c. This is BOD. Okay? So yan po yung formula natin for the VC. Then yung QU natin ay still yun pa rin naman. Ano na yung value natin kanina? 441.6. 441.6 times yung area shaded. Okay, so ano yung magiging area shaded natin dito? Okay, so yung area shaded natin ay syempre yung nasa labas pa rin. Okay, so ito pa rin po yung area shaded natin. Okay, so ito medyo mas mahirap yung kanyang area shaded. Now, para makuha natin yung area shaded, this is simply, okay, area shaded is simply area of the footing minus area nung inner. Okay, tawagin na lang nating inner. Okay, ano yung area ng footing natin? That is 2.5 square. Less, yung inner natin is simply x times y. Okay, x times y. Okay, so ito na yung area shaded natin. Ayan. So, okay na yan, no? Siguro. Or substitute na lang natin. Since x is equal to y, pwede natin sigurong gawin area shaded is simply ano bang 2.5 square. Okay, so 2.5 square is 6.25. Okay? So 6.25 less, ayan. Gawin natin 0.4 plus d tapos square na lang siguro. Okay na siguro to, na? Okay, so yung area shaded natin ay I think simplified na rin naman yan. Okay? Or pwede pa siguro simplify, pero Try natin, no? Baka kaya nung calcu naman. So, 6.25 minus 0.4 plus d is square. Okay? Ayan. So, try natin ulit i-substitute lahat. 0.75 times 1/3. Lambda natin, walang binigay. Times F prime C natin. Ano yung F prime C natin? 20.7. This is 20.7. Times yung BO natin ay in terms of D. Okay, 1.6. Naka-meter na rin naman for D. Times D. Okay, then, don't forget yung 1,000 dito sa left. Then, equate this, or equate this to 441.6 times quantity 6.25 less 0.4 plus D, then square. Okay? So, ayan, pwede na natin siguro isolve dito yung D. Okay? Shortcut na lang natin sa may calcu natin, na? So, pagsamahin muna natin lahat ng constant dito sa may left siguro. So, 0.75 times 1/3, okay, times square root ng 20.7, okay, times 1,000. Okay? Then, divide this by 441.6, yung galing sa right side. 441.6. Okay? Then, store natin ito ulit sa A na lang din. Okay? So, ang mangyayari, sige, sulat muna natin siguro. Oops. Okay, so ang mangyayari siguro dito, gawin natin, no, stored value na A times, okay, 1.6 plus 4D times yung D is equal to 6.25 minus 0.4 plus D square. Okay, stored value yung A dito. So, D natin dito is equal to, okay, at least kahit pa paano na-simplify natin. 1.6 plus 4x, okay, unknown, times x ulit is equal to 6.25 less 0.4 plus x is square. Okay? Then, try natin i-solve. Okay? So, ayan. Kaya naman, no? So, D natin dito ay 0.548. 0.548. Okay? Meters. Alright. So, obviously, between the two, okay, effective depth na bigay ng wide beam ay 0.459 versus effective depth na binigay ni punching na 548. So, apparently, of course, yung mas makapal, ito yung nire-require ni punching. Kapag ginamit natin yung 459, ay magfe-fail na automatic si punching. Pero kapag 548 yung ginamit natin sa wide beam, papasa siya kasi minimum niya naman yung 459. Alright, so gagamitin na natin dito ay yung effective depth due to punching. So, ito yung mag-govern. Now, ang tanong dito ay yung thickness. Alright? So, paano ba yung thickness dito? Okay? So, alam natin na since punching ito, okay, if we remember, ang effective depth para sa punching ay, okay? So, recall natin, no? Meron tayong bakal dito. Tapos, top bar. Kapag MU, okay, kapag ka MU, ang effective depth natin ay yung nasa bottom bar. Okay? Kapag ka naman wide beam, ang effective depth natin ay yung nasa top bar. Okay? So, ito sa wide beam. Then, kapag ka naman punching, ang effective depth natin ay, sabi ng code, yung pagitan ng dalawa. Average of the two. Ayan na. So, ito naman yung sa may punching. Okay? So, para makuha natin yung thickness, pwede mong gamitin yung itong concept. Okay? The thickness of the punching is simply equal to, pwede mo itong gamitin. Okay? Thickness thickness is the effective depth plus bar diameter, okay? Bar diameter plus meron tayo ditong clear cover, okay? Plus clear cover. Pwede po ito, no? Ito na yung magiging thickness mo, okay? Kaya lang, kung nagde-design tayo, gusto nating mas makapal pa na thickness actually, no? So, regardless kung saan dito yung nag-govern, ang magandang gamitin na effective depth ay yung measured from the top bar. Bakit? Kasi kapag ginamit natin yung sa may wide beam na part, okay? So, kung ito yung ginamit natin, yung ibibigay sa atin na thickness is greater, no? Kasi dito mo i-measure yung effective depth. So, magdadagdag ka pa ng kalahati ng bar. Okay? So, that is equal to, so in formula or yes, in numbers, that is effective depth plus kalahati na rebar plus isang buo or simply 1.5 diameter plus meron din tayo ditong clear cover, CC. Okay? So, kapag ka ito naman, mas maliit. Okay? Yung thickness natin dito ay effective depth plus half nung diameter plus concrete cover. Okay? So, gusto natin yung mas makapal na thickness. So, among the three, yung formula ni wide beam na thickness yung magbibigay ng mas makapal na thickness. And kung gusto nating mag-design, gusto natin itong mas safe, no? So, dito na tayo mag-focus. Alright? So, ang gagamitin natin ay ito. Although punching yung nag-govern, hindi ito yung gagamitin natin. Rather, this one. Okay? Oops. Since nandito ka na rin naman sa part ng video ito, maaaring pa-like, share, and subscribe ka na rin sa ating channel. Thank you. Yung thickness natin ngayon ay, okay, so in mm na lang siguro, 548 mm for the effective depth plus 1.5 diameter of the rebar. Okay, so walang binigay na diameter of the rebar. We assume, no, for example, gawa na lang tayo dito, diameter of the rebar to be equal to 25 mm. Okay, for our example lang naman, no? So assume natin 25 mm yung binigay na rebar. Okay, so 1.5 diameter 25 plus the minimum clear cover for or concrete cover for the footing is 75 mm according to our code, no? So ito po dapat by heart alam natin. So now the thickness is equal to 548 plus 1.5 of the 25 plus 75 mm. Okay, so we have now 660.5 mm. 660.5 mm. So, ayaw naman natin na may butal, no? So, pwede natin tong gawin, round up by 5 mm. Pwede natin tong gawin, 665 mm. So, kapag ka ito yung thickness natin, ibig sabihin, pasado na yung ating footing in both wide beam and the punching. Okay? So, allowable is equal to actual lang naman lagi. Okay? So, ayan.